So, hello again, guys. Today we are going to work with challenge number 10, and if you check the description of the challenge number 10, you will see that the objective of this challenge is to build an element that moves a protective surface that is going to block the sun depending on the sun protection. So if you remember, the sun moves depending on the day, time, and so I want to cover maybe my car or maybe my computer of the sunlight. So I need to put a surface that moves in the same manner that the sun moves, so I cover my computer or my car from the sunlight. So for this I'm going to use this little guy. This is a photoresistance. If you wonder how this works, you can check the video about photoresistance. But really fast, this photoresistance changes its value, its resistance value, depending on the light about this over this surface. So if I cover this, I have a full reading. If I only cover one part of the surface, only one part receives light, and so the resistance change. And if I don't cover the surface, all the light goes over this surface and I have another reading. Also, I'm going to use this blue guy that is a servo motor. This servo motor, it's more or less like this, like the motor used on the previous challenge, but the difference is that with this I can control the position of the motor axis. I can change the position. With this, it only moves on one direction, another or another direction, and it keeps moving forever. So I have positive connection, negative connection, and that's it. It only moves. And here I have three connections. The brown is the negative, the red is the positive, and the orange is the control signal. In this orange I send the position that I want to get with my servo motor. So the difference between a normal motor, a normal direct current motor, and a servo motor is that in a servo motor I can control the position of the axis. So to use this servo motor, I need to use again this motor control shield for Arduino card. So you know this from the previous challenge. You need to attach it to the Arduino, and that's it. The new thing about this challenge is that now we are going to use the servo connection. If you see, I got servo 1 here and servo 2 here. So I got two connection, two ports to control the servo position. So if I want to control the motor, the servo motor, I need to connect it in here. Now, I don't know if it is clear in here, but I got minus connection, plus connection, and signal connection. And if you are not able to see this in the video, okay, I can show it maybe. Okay, I guess that's it. Yes, that's it. This is minus connection, plus connection, and signal connection. So I need to be careful to connect it in this manner. Remember, brown is negative, so negative is on the left, positive is on the middle, and the signal is the orange and it's in the right position. Is this clear? Very good. So I'm going to connect this on SER1 port, and you will see why I'm going to use this port. But for now I am going just to connect it like this. Very good. Now let's see the circuit. This is the circuit. So as you see, it's really easy, and then we are going to follow these instructions. First, I need to provide power into my breadboard. So I need to connect 5 volts to the red line and ground or GND to the negative line. So I'm going to use, maybe to make this more educational, I'm going to use 5 volts, the red one in here. Remember, I got 5 volts. It's not visible. Okay, there it is. It's not clear, but you should remember this line is for 5 volts, this line is for GND, and this line is for inputs. Do you remember? From A0 to A5. So I'm going to connect in this the positive, there it is, and it goes in the red line of my breadboard, sorry. And my GND or my ground goes to the blue line of my breadboard, and that's it. Now I got this connection and this connection. Now these blue guys are potentiometers, and the potentiometers are these. I am connecting the potentiometers in this manner because I need to create a voltage divider. If you want to understand the theory about voltage divider, you can check the video about this topic. But the most important part is that I need to build this because we don't have a proper resistance value on your kit. So I need to use what you have in order to get this to work. So this is not the best way of doing this, but we are going to do this because you are not able to buy a new resistance or change this value. So I need to connect the left leg of one potentiometer, this is the left leg, into the negative line. So I use this wire, this, to connect from negative to this line. So anything I put in this line is going to be connected to negative. So I'm just going to insert the left leg of the potentiometer in the same line of this black wire, and that's it. Really good. I have now this connection. Now the right leg of this potentiometer has to be connected with the left leg of another potentiometer. So I'm going to put this in here, and I'm going to use this yellow guy to connect this leg with this leg. So I'm going to connect this leg with this leg. So I put the yellow connector in the same line of the right left of this potentiometer, and the other connector in the same line of the right leg of this second potentiometer. You see, this is the same line with this yellow connector. Now I need to repeat the same process for the third potentiometer. So I put it in here, and I'm going to use the brown to connect the same line of the right leg of this potentiometer with the left leg of this other potentiometer. So there it is. Really easy. I don't know if you're able to see. I lose connection with this, but it doesn't matter. I can put it back later. What I want you to see is that I got the right leg, the left leg of this potentiometer goes in the same line with the left leg of this potentiometer, and the right leg of this same potentiometer goes to the left leg of this potentiometer, and that's it. I got all this connection. Really good. Now, as you can see, the right leg of the last potentiometer goes to one leg of the photoresistance, and the other leg goes to positive. So I can use two new connectors to produce this electrical connection. Or, let me show you, I am going to put this leg in the same line, this leg in the same line of the right leg of the potentiometer, and the other leg goes to positive. You see? I don't know if it is clear, but this leg goes to positive and the other leg goes in the same line of the right leg of this potentiometer. So I got this connection, and instead of using two wires, I put this leg in here and this leg goes in here, and I saved two connectors. It's up to you. If you want to use these connections so you follow the circuit and it's easier for you to understand, it's fine. So I only need to add the input to my card, and it is going to be connected to A0 input, and you will see in the program why I used A0. But right now I only want to connect A0 to the same line where the right leg of the last potentiometer goes with the leg of the photoresistance. So this connector goes in the same line. That is it. You see, it's in the same line with the leg of the photoresistance and the right leg of the potentiometer. And now it goes to A0, and that's it, A0. I need to put back this to positive and to ground, and that's it. That's the way it should be. Very good. I want you to be able to see the photoresistance, so I'm going to move this way so it won't get in the way, and also this. I'm just moving this because I want you to be able to see the photoresistance. Okay, so now let me plug this on the card, and that's it. And now if you see, right now the full light of the light bulb, in this case, but it should be the sun, goes into the surface of the photoresistance, and I got this position on my servo. And so if I cover the photoresistance, the position changed. You see? No cover, a little bit covering, more, full covering. You see? The position of my servo motor changed depending on the light over my photoresistance. So I can attach the protector screen over the axis of my servo motor, and so the protective screen is going to move in the same manner of the sun, and then I'm going to protect my computer or my car or anything. So the main topic in here is controlling the position of the servo motor with the light over the photoresistance. So again, I cover and it changed. I remove the cover and it goes back, and that's it. Really good, really nice. Okay, now this is really nice. Now let's get on the circuit, the code, the program. I got all these instructions. As I told you, include it's an instruction to call a library, and as if you remember, a library is like a manual used to control external elements. For example, to control the liquid crystal display or to control the serial port. So in this case, I am using again this library that I told you that is developed to control this card. So this library is the manual that shows to the Arduino how to control this card, the card used to control the motors. Also, the servo motors are different from direct current motors because I need to control the position of the axis, and the position of the axis is through this signal cable, the orange cable. In this cable I send a signal that tells to the motor the position that I want to get. So I need to use a special function of the Arduino card. The position of this servo is controlled by the PWM signal. PWM stands for pulse width modulation. So to make it easier, I send a signal that changes constantly, and depending on the frequency, actually it's not the frequency, it's the length of this signal. Depending on the length of this signal, it's the position. So it is a special function for the Arduino, and so I need to also include a manual to allow the Arduino to use this instruction. And also I want to display the position of my motor on the serial port, so I'm using again the serial port. Now I want to call my servo for a name, and I don't have imagination, so the name for my servo is name servo. Really intelligent, right? If you want, you can change in here like Little Blue or my big guy or something as you wish. I don't have imagination, so the name of my servo is name servo. Now I need a variable to specify the port that I am using to read the value of the photoresistance. So as I told you, I used A0. That's why I connected my signal to A0, this blue connection. I can change it, yes, I can write it A1, and then I need to connect this to A1, and I can write in here A5, and I can connect it to A5. It's up to you, but I need to specify which port I am using. So I am using A0. Now I need to read the position of my servo, so I need to create a variable to storage the value for the position. So I create the variable called servo position, and its first value is 0. Also I need to store the value of the resistance, in this case my sensor. So also I need to create a variable called sensor value, and its original value is equals to 0. It doesn't matter the original value because I'm going to write a new value in these variables. And this is all the setup of my program. Now let's go to the main body of my program. So I need to specify the port that I am using to control the servo. And as I told you, serv number 1 is the port number 10, and serv number 2 is the port number 9. So if I want to connect my servo in servo number 2, I need to remove this and put it in here, and then I need to write in here the port number 9. But I don't want to use number 9, I want to use number 10. So I put it back, and that's it. And this is, as I told you, the baud rate about the serial communication. We have worked with this on challenge number 2, so it's nothing new. If you don't want to bother about this, just remember this value, and that's okay. Now, this is the program that it's going to be executed just once. The first time I need to say, okay, my servo is connected to serve 1, and the baud rate of my communication is this value, and that's it. Now the program that is going to be executed over and over goes inside of this section, the void loop. So first of all, I need to read the value of my photoresistance. And remember, in the previous challenge we used A1 as a digital input. It was I push the button or I don't push the button, 1 or 0. So it was a digital input. But now I have several values for my readings about the photoresistance. So now I need to use an analog read. Now A0 is going to work as an analog input. So I need to specify analog read from A0. Remember, sensor pin is equals to A0. So I can write here A0, or because I say that sensor pin is equals to A0, I write here sensor pin. So from A0 I'm going to get an analog reading, and this reading is going to be stored in the variable called sensor value. Now this sensor value is used to calculate the new position for my servo, and I divided this value by 2. This value, this operation, it's my adequation of the sensor value, because I have experience with this, and I know that if I divided the sensor value by 2 I get a better result. So don't worry, when you get more experience with this you will be able to choose what adequation, which operations I need to perform on the sensor value to get a good position value. Okay, now I store this result on the variable called servo position, and I send this value into my serial port. So I'm going to be able to read the position on my serial port, and also I send this position to my motor, to my servo motor. So I say, okay, servo motor, write your position with this value, send to your position this value, and I got a delay. And that's it. Well, see you in the next video and have a good day.